We have gone over how data is represented in a computer by numbers, right? So an image is represented by a matrix of a whole bunch of different numbers. And for example, this matrix of numbers can correspond to the brightness of a given color at a given pixel. And so what we've also shown is that certain data points can be aggregated to be able to create these things known as features, where a feature encodes some qualitative idea about our data, right? So an image can have a mean value of red, right? So we can have an average amount of red or an average amount of green, and this average amount of red can tell us a lot about the whole figure. And so what we usually do is we take our data and first convert it into these more qualitative features. And somehow from these features, like how much red is in the picture, how much green is in the picture, we want this computer to spit out, yes, it's an apple, or yes, it's a banana. And the way that we're going to do that is we need a data model here in the middle. So what exactly is a data model? A data model is some function, f of x, where what we do is we give it our features. So we give it our features, and outspits a classification. Now remember that a computer doesn't know apples or bananas, instead it knows numbers. So what we do on our side is we interpret the numbers to have meaning, right? So we say that 0 means that the computer thinks it's an apple, and 1 means that the computer thinks it's a banana. And so from there, what we have is some mathematical model that corresponds to whether we have an apple or a banana. Now these mathematical models, or these functions, should be a function which goes between 0 and 1. So we can say that when the number is close to 0, we have an apple, and when the number is close to 1, we have a banana. And our choice of feature, or our data point, what its features are, give us this change in classification. Where if we have a bunch of red, we might be over here. And then for the images which have a bunch of yellow, we'd end up being over here, and therefore our computer would tell us 1s and 0s corresponding to bananas and apples. Now, what kind of function should we choose for this? A popular choice is known as the sigmoid function. And now the sigmoid function is defined by this function right here, where this w and b are values that have to be determined. So what a sigmoid function looks like is it's this function which goes up between 0 and 1. It can never go below 0, and it can never go above 1. And what these numbers correspond to are shifts and squeezing of this function. So a b, well, one way to explain it is that, let's say we have a bunch of red here, and now let's say we have our switch to bananas happen over here. Well, maybe our sigmoid that we've chosen here might not be correct, but by changing this value b inside of the sigmoid, we shift over this function such that now it does something like this. And then it will correctly classify apples and bananas. What this w does is it makes it more steep or less steep, so that way we can have a longer part where we are unclear or going through a transition between apples and bananas. So this shows you how we can have a simple choice of functions with a few parameters inside of it, and use that to be able to computationally encode the idea of features to classification. What I want to show you next is exactly how this sigmoid function looks like by investigating it computationally.